Welcome to our perfect classes. In this class, I will discuss about compiler design. First concept I will take from automata, that is parse tree or derivations. Now, what is a parse tree? The the process of deriving a string is called as derivation. Second, the geometrical representation of a derivation is called as a parse tree or derivation. First derivation is leftmost derivation. Leftmost derivation means the process of deriving a string by expanding the leftmost known terminal at each step is called as leftmost derivation. I again repeat, what is leftmost derivation? The process of deriving a string. How? By expanding leftmost non-terminal at each step. That is known as leftmost derivation. And second point, the geometrical representation of leftmost derivation is called as a leftmost derivation tree. Now I am taking example. For example, consider the following grammar. S implies A, small a capital B, or small b capital A. S implies A capital S, B capital A and small a. Capital B implies B S or A B B or B. This is ambiguous grammar. Now let us consider a string. A string W A B B A, again triple B A. Now let us derive the string W using leftmost derivation. Now first of all, you take S implies A capital B. In first step, using B implies A capital double B. That means A as it in place of B, we will take ABB. Now again using B ABB. Now again A, instead of this B you will write ABB B. Then now using B implies small b. These things are already given in question, in statement. Triple A. Now BB. Take one capital B as a B and other capital B as it. Now again take using capital B small b. Triple A BB and one capital B. After that again using B implies A capital BB. A B B A B B. Now using capital B implies small b. A B B A B B. Now take using B implies small b S. Triple A B B A B, and instead of this B, in place of this B we will write B capital S. A B B A B B. Now using S implies B capital A. In place of S, B capital A. Now again using A capital A implies small a. A B B A B B B A. Now you can see you will get string that is required in statement. Now this is convert into parse tree. How to solve through parse tree? First of all, you take S A B, then take A B B, then take again A B B, and take these B B small b, and after this take again A B B, this B small b, and this B B or S, and this S will be B capital A, and this A will be small a, and you will get A B B A B B, again B, and A. You can see answer. This is the leftmost derivation. Now next, second point is rightmost derivation. First point, the process of deriving a string by expanding the rightmost known terminal at each step is called a rightmost derivation, and geometrical form is called parse tree. Rightmost derivation tree. Now next, taking same example but solve from right side. S implies A B or A B capital A. S B A and A. B implies B S A B B and B. This is unambiguous grammar, and we have to find this string. Triple A, double B A, triple B A. For this, first of all, in case of rightmost derivation, you have to take first S implies A B. Now take in place of A this A B B. Now again A B, and take in place of this B this value again A B B. After that A B A B, and last B's place I will take B S. Again A B B B. In place of S we will take B A. Why? Because this is the rightmost derivation. A B B. Now B B. In place of capital A take small a, then again a, b, a. Now in place of b, take small b, and after this a, in place of this b, again take a, b, b, a, b, 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 a. Now take a, in place of this b, in place of this also b, a, triple b, a. You will find your string. Now solve it by tree. Rightmost derivation tree. S A capital B, then A B B. Now then A A B B, A B B B. Take here B B. Take here B. Take here B S, and take here B A, and take here small a. This is the rightmost derivation. A B B B A, again B B B A. You should keep in mind that for unambiguous grammars, leftmost derivation and rightmost derivation represent same parse tree. For unambiguous leftmost derivation tree and rightmost derivation tree are same. For ambiguous grammars, leftmost, for ambiguous grammar, leftmost derivation tree and rightmost derivation tree are not same. And which example I have solved? It is in this example, leftmost derivation is equal to rightmost derivation. So we can say grammar was unambiguous, and that is why leftmost and derivation, rightmost derivation represent same parse tree. Thank you. If you like this video, please like and share my channel with your friends. Next upcoming videos.